Greedy algorithm, huh? So let's look at a problem where look at a minimum spanning tree. So a tree is a connected graph with no cycles, and the spanning tree is a subset of edges that contain all the vertices. And a minimum spanning tree is finding a spanning tree of minimum weight edges. And that's what we'll do in this in upcoming two algorithms, kruskal and prims. We'll see how we can get minimum spanning tree with a greedy approach. First, uh, let's look at prim's algorithm. We're going to start with a empty set S and a set with vertical verses that are not added in the minimum spanning tree. Then we are going to find minimum weight edges from the vertex to the adjacent vertex, add that to the minimum spanning tree. We'll start by keeping all of the vertices in a priority queue that are not in the MST, choosing starting vertices arbitrarily. We will run a loop until our priority queue is not empty. So at first our priority queue is going to hold all the vertices of what we have. Then we're going to take out one by one by one. So let's see how it goes. We will remove a vertex from the priority queue based on the minimum weight, and then update the weight of the adjacent vertex in the queue. So if you have like a to b over if you have a already in set s, then you take b. So now b is in the minimum spanning tree. Then the adjacent vertices like c, d or g that you have are also their weights will be updated from infinity to some lower value. So what we will do is we will run a loop until the priority queue is empty, all the vertices in MST. We'll remove a vertex from priority queue who's based on the minimum weight, and then update the weights of the adjacent vertices. Running this will give us a minimum spanning tree. Once again, being greedy by picking up the minimum weight edge gives us an optimal solution, but we have to be greedy and smart. In this approach, we begin by looking for the global minimum weight edge. Although we're looking for the low weight edges, we have to check if the two vertices are already connected. In that case, adding those two vertices will have cycles, and we don't want that. So what we can do is we can check them by using disjoint data sets, calling find function twice for those two vertices, and if they return the same value, then they are in the same set, and if not, then we can add those two vertices or draw an edge between them, whatever helps you visualize it. If they are not, we use union function. So if they are not, we will use union function to add them. So what's the algorithm say? So we begin by creating a set with one vertex, then sort the edges by weights in ascending order, then for loop for edges. So and check if the two vertices are not in the same set. It can be done by calling find set twice, and if both return same value, then they're in the same set. Else we can add it in the MST using union. So that is it about kruskal algorithm. So we see that in Prim's algorithm and kruskal algorithm, being greedy help us get a minimum spanning tree, and the solution is optimum, and it depends upon what data you have. You can use either kruskals or Prims, whatever suits you. But so what is greedy algorithm? Well, you approach a problem with a mindset that the local optimum solution is the global optimum solution, but that's not always the case. Mostly it's when you want to maximize or minimize something, and even then you have to make some tweaks with the data that you get in order to get the optimum solution. Let's look at a problem where a thief has a bag and can steal as many things that can fit in his bag. Yeah, I know that is a knapsack problem and should have covered it in the TP video, but let's look at here. With one extra condition, he can even take some fraction of a thing if the bag doesn't have the space to accommodate the whole thing. So a piece of a particular thing can work as well, and it will cost the same. So the thief can begin by taking the most expensive thing first to maximize the profit, and expensive until the bag is full. But he can do better. Uh, so let's pause this video, and you can think how it can do better than just taking the most expensive item first. Well, he can take a ratio of the price to the size. So size about price will give us a ratio of and sort them in descending order will give you what has the highest fraction, and based on the fraction and the weight, he can actually get better profit than when he was just picking the most expensive item first and second and third. So this tells us that if you are greedy, you can get more gains. But if you are greedy and smart, then you can even increase your gains more. And that's what real twisting the facts that you have, twisting the data that you that is given to you uh, to get better results. Okay, let's so I think that's it for the greedy algorithm. And if you like this video, uh, subscribe, and I hope I see you in my next video.